Hi, I'm Lex Wilson. I'm a student at Nottingham University of Biological Sciences, and today I'm going to tell you about macromolecules. Macromolecules, the subject of our daily conversation.
How about those macromolecules? How about the what?
From only a few minerals, carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, all organic life is made. 3 of the 4 macromolecules, carbohydrates, proteins, and nucleic acids, are all polymers. Polymers are chains of units called monomers. There are a lot of kinds of monomers, and these compose all organic molecules, with ATP as a source of energy. Because you were wondering, monomers connect through covalent bonds, also known as ester linkage, through condensation reaction. The macromolecules separate through a process called dehydration synthesis. To start off, the carbohydrates, the carbs, the carbose. Carbs are made of carbon, hydrogen, and oxygen and have a 2-to-1 ratio of 1 carbon, 1 oxygen, and 2 hydrogen. Carbs are held together by a glycosidic bond. Carbs are very energy rich, and they're composed of monosaccharides, disaccharides, polysaccharides, or glucose. These monomers bond to form small sugars, double sugars, starches, cellulose, and chitin. Next up is lipids. Lipids are made up of saturated and unsaturated fatty acids. Fatty acids are chains of carbon bonded with hydrogen atoms attached to available carbon electrons. Saturated and unsaturated in the case of fatty acids are determined by whether the acid has a single bond or a double bond. The lipids known as fats and oils are built of 3 fatty acids connected to 1 glycerol, which is an oxygen connector. In water, the carbon, oxygen, hydrogen loses a hydrogen atom and becomes an acid, therefore a fatty acid. Nucleic acids, DNA and RNA, are chains of nucleotides. There are 5 types of nucleotide bases: adenine, guanine, cytosine, thymine, and uracil. These bases attach to deoxyribose for DNA and ribose for RNA. All organisms use DNA to store genetic information and RNA to access genetic instructions. Next up are proteins, the most diversely functioning macromolecule. Proteins are made up of amino acids connected by peptide bonds. There is a primary, a secondary, and a tertiary structure. Primary structure describes the order that amino acids link to form a protein. Secondary structure is how a protein is shaped. The secondary structures are alpha helix or beta pleated. Alpha helix resembles a coiled spring, and beta pleated looks folded or pleated, hence the name. Both of these are held together by hydrogen bonding. Tertiary structure refers to the 3D structure of polypeptide chains of proteins. Fun fact about proteins, by the way, they make up your hair, your nails, and egg whites. And that's macromolecules. Thank you.